Welcome back to VTU e-Shikshana program on computer aided drawing or graphics. Now we will solve a problem on straight line which is inclined to both the planes. In previous sessions we worked out the problems on lines which is inclined to HP or VP. Now let me work out a problem which is inclined to both the planes. Let me take a problem. A line AB 8 mm long, inclined at 30 degree to HP and 45 degree to VP, has its one end A 15 mm in front of VP and 20 mm above HP. Draw three views. Normally, three views means it is front view, top view. At your wish, you can keep left view on right plane or right view on left plane. Preferably, we go for left view on right plane because of continuity of the direction and also easy to go for space management. Now, before this, let me discuss the inclination with respect to HP and inclination with respect to VP independently. Now, here is the problem. One end of the line is 20 mm above HP and 15 mm in front of VP. Now, the line is inclined at 30 degree to HP and 45 degree to. In one go, we cannot solve the problem as we did in the previous cases. Actually, we have to first draw inclination only with respect to HP, get the projections, and draw inclination to only VP, get the projections, and then combine both. Definitely you will get the final result. Now for this, as prerequisite, I will show you two simple models wherein I have the line which is parallel to VP inclined only to HP by 30 degree. You can see that the line is parallel to VP means it is parallel to VP, it is inclined to HP here. Now, if you rotate like this, you will get this projection you have to draw first. Then you have to draw one more figure which is assuming that it is parallel to HP and inclined only to VP. You have to draw. See here again I have taken same reference 15 mm above HP one end and 20 mm in front above HP and 15 mm in front of VP. This is what. Then you take this. So with these two figures, we can draw the projection of a line which is inclined to both the planes. I will repeat how exactly you get the projection of the line inclined to both the planes. First, we have to draw the inclination to HP, then inclination to VP, or otherwise round also is possible. First, you give inclination to VP, draw the projections, then give inclination to HP, draw the, but only condition is you have to have a single end as the reference end. From the same end, you have to start both the items, inclination to HP and inclination to VP. Now, let me utilize this reference and draw. So, to start with, you have to draw XY line. Let me concentrate only on the front view, top view, not the side view now. As usual, XY, VP, HP, VP, HP. Now, draw vertical projector to fix one end of the line. One end of the line is A. Check twice, 15 mm in front of VP. 15 mm in front of VP. This is A. Do it carefully, neatly you mark when you are working on manually. If it is computer, you keep A little away from the point and also dimensioning lines. Next comes the distance from HP, 20 mm above HP. Mark carefully. This is A dash. Dimension it, maintain sufficient gap. This is 20. Now, as we discussed earlier, let me draw the inclination to HP. Okay, and then inclination to VP. As prerequisite, let me draw some simple drawings. These two are very important and basic drawings. A dash, B dash, AB. This is A dash, B dash, again AB. This is having some inclination to HP, inclination to VP. Just observe here, whenever a line is parallel to HP, I mean XY line, always opposite to is true length. Other way around, whenever a line is inclined to HP, corresponding apparent length you get. If it is parallel, this one is always true length. Here also true, projection is parallel to XY line, definitely this one is true length. Okay. Now, let me draw inclination to HP. Let me utilize. Otherwise, keep this way. True length AB. True length AB 80 mm long. That is given. Theta equal to 30 degree. Phi equal to 45 degree. This is what given. You have to draw with this the projections. Now draw a line inclined at 30 degree to. Okay. Measure 80 mm. Okay. I am measuring 80 mm. Say B dash. Initially, let me take A dash, B dash only, assuming that it is only inclination to HP. Now, draw projection, draw the corresponding top view. Assuming that it is parallel to VP, inclined to HP, we are working here, it is theta equal to 30 degree. As I told you, during dimensioning, you have to keep this way. Now, A dash, B dash is front view, AB is top view. This is one set of projections. Let me name this particular set as true length 1, apparent length 1. Because we have two conditions, one inclination to HP, inclination to V. So, this is the projection of the line when the line is inclined only to HP and parallel to VP. Now let me draw one more set of projections with the respect to same fixed end, that is A. Now draw a line inclined at 45 degree, take same length 80, and then what to name? You are supposed to name this is B. Here you see AB. Now corresponding, already A dash is there, A is there. Now correspondingly you have to keep this projection ready till the fixed end you have to move and then fix. This is B dash. So we got confused to A dash B dash and A dash B dash twice. Again AB, because we have repeated twice for different angles. Now let me fix this angle. Given angle, true inclinations, these are called true inclinations given. Okay, now this is what we did. We drawn the true length and then projected and got the corresponding top view, apparent length 1. Now this is true length, same true length, I am naming this as true length 2. Even though it is same, I am keeping, because position is been changed and corresponding procedure is there you have to follow. And this is true length 1, apparent length 1, this is true length 2, apparent length 2. So this is the set of basic figure one has to do for completely understanding this straight line problem. This is again very important figure also. After this, it is very interesting to note that the line, assume that this is vertical plane, ground is horizontal plane. I am having one stick with me. Forget about line. I am fixing this stick at one end and then rotate this. Maintaining the inclination to the ground same. For example, 30 degree it is given here. Let me maintain 30 degree only and then rotate. Maintaining 30 degree, rotate. See, we observe that the top end height never changes. It remains maintained same. Even I can keep this reference. See, can keep this reference. This plane is parallel to the ground. I will keep this initial position inclination only to HP and parallel to VP. Now I will rotate this, give inclination to VP. Okay, now I will remove it. If you measure, initially say it is 1 meter, here also it measures 1 meter, it measures 1 meter. That means the path of the moving end, whenever you start giving inclination to VP, is remains same with respect to ground. In this case, it remains same with respect to XY line. So naturally, this line we have to draw and call this as locus of B dash and B. That means total moving end B. This is fixed end, this is moving end. So the moving end path we have to locate, because final position lies on this line only. This is not final position, this is initial position. Giving inclination only to HP. This is the initial position. Okay. So that's why we have to change this name. The B dash is there, this is final. Now I will change this to 1. If this is 1, to avoid confusion, let me make this 2. With respect to VP, I keep it 2. You can keep your initial. My initial is MSP. I can keep this as M, this as S. Okay, no problem. If this is BM dash, this becomes BM. If this is B1 dash, this becomes B1. That's all. Now, if this is B1 dash, this becomes B1. Very simple way of working. Now, same way, if I keep this stick here and fix one end and maintaining inclination to VP 45 degree or whatever given, and start giving inclination to HP. So the moving end locus or the plane on which it is moving is parallel to XY line. That means the distance from VP to this point never changes, even though it moves up with respect to giving inclination to the HP. So I can always draw the locus through B2. This is locus of B2 and final you get B. Here initially is B1 dash, here it is B. B1 dash, B, here this is B2 and B. Now unknowns are the positions of B1 dash, B dash and B. So how to find out? Now we came to know the initial position of the line with respect to HP and initial position of with respect to VP and corresponding apparent lengths top view. Okay, now I will make you to understand in a better way. Assume that a given inclination to HP. This is the actual line. This is AB, capital AB. And with some particular condition given, it is on HP or 20 mm of HP, etc. Let us not worry. This is its top view for a given inclination. This is top view. This is 10 centimeter. Say this is 6 centimeter. Okay. Now it is inclination only to HP and parallel to VP. Just observe here. Now you start changing inclination to VP. Now what happens to this length? This length is not changed. Suppose that this is 10, this is 6. Even after giving inclination to VP, this remains same. That means initially you get some top view, that length itself is final top view. So what I can write here for understanding purpose, apparent length 2 is nothing but, apparent length 1 is nothing but final top view length. Similarly, front view, you take a front view, you will get the same thing. For example, this is the inclination to VP you have given some angle, 40 degree, 45 degree, whatever. This is 10 centimeter, this is 5 centimeter. Now, parallel to HP, inclined only to. Now I start giving inclination to HP. This length never changes. So whatever the projection you get, same thing remains, because the angle between the VP and this line never changes. So naturally, we will get same length. That means this particular length is nothing but final top view length. So this is very important to understand. Suppose that you get B somewhere here. As I told you earlier, this will move and then take the position of the particular height. That height remains constant. This height remains constant. Somewhere you will get B dash. Now, where exactly you will get B final B dash. How to know? See, here is the answer. We understood that whatever the front view you get, if you are giving inclination to VP, if you rotate it, same thing remains same. So its final front view is this. So we have to draw an arc using this radius, that is final front view length equal to radius. This final top view length, final front view length equal to radius. Draw an arc. That's all. Intersection gives you final B dash. It's very interesting. This one is the final front view length. Here is the path, and then rotate. So you can also simply make you to understand I have PQ equal to 100 centimeters, and you have point P here, and locus of Q is here. This is locus of Q. Now, how to mark Q? Take 100 mm equal to radius, draw an arc. You will get the final required line and orientation. Same way we are working here. I know final front view length, I know fixed end, I know the locus of B final, B dash. This is B dash actually. B1 dash and B dash. B dash, then you take this radius and draw an arc. There are three paths are important here to understand the concept of straight line. You can work any problem on straight line. I will tell you after completing this. B dash, B1 dash. A dash, B1 dash is initial position and true length on true inclination. If you join this, you will get final front view position and the angle. This is called apparent angle. Actually, this is not the actual angle, is apparent angle. That's why we call this as alpha. If you want, you can measure and say how much it is. Not necessarily all the time. Unless they ask, don't measure. Simply say alpha. I told you how to keep alpha beta in the computer. Now, how to get, see, we got the front view. How to get the front view? There are two methods of getting front view. Same procedure you follow. Final top view length is this. The one end is fixed for the top view. Other end exactly on this line only. So definitely same procedure you can follow. Rotate the final top view length and then fix this. Intersection of this arc and the locus of B2 and B. Already we have fixed this. B2 and B gets you B. Okay, join these two. Now, this particular angle is referred to as beta. So much. If you want, you can find. Otherwise, leave as such. Unless it's demanded, don't do it. Now, it is interesting to know this particular zone. Again, this particular zone. Now you can see horizontal line, vertical line. I will create vertical line. It is very important line, and then curved line. Here we have curved line, horizontal line ready. Now, what exactly vertical line is with respect to this zone? Line joining B dash and B must be in a single vertical projector, because similar to A dash, you must have B dash. So if I draw a line passing through this B dash, it must coincide with B. See, vertical line must coincide with B. So this is very important. AB is the top view, A dash, B dash is the front view, and this particular distance is referred as distance between end projectors, final projections, distance between end projectors. So normally in questions you get data on distance between end projector and one end of the line, inclination to the line either respect to VP or HP, they may not give or they may give. So all depends. They give a question suitably so that you have to draw the projections. This is the master problem or standard problem on straight line. So I will repeat. First, you draw inclination to the HP, get the projection. Next, you draw inclination to the VP, get the projection with respect to the fixed end, and see that these projection lengths, apparent length 1 and apparent length 2, are intact. Then draw locus of those two apparent lengths to strike the locus of moving end, here B2 and B1 dash, and you get B dash and B ready. Suppose that you don't want to waste your time and keep only B dash and find B. Yes, you can do it. Get this B dash and then draw projection. Automatically you will get. Or other way around, you keep B first, rotate this and get B first, and then project, you get B dash automatically. But for all practical purposes, show these two arcs and you can check actually whether you got correct answer or not. Okay, even in computer, if you commit small mistakes, you will get deviated. You can, if you zoom it, you will find the difference. But carefully you have to do it. Manually, I don't think you get any problem. But you are working on a sheet, there always some error is there. Okay, so this is about the drawing of projections, front view, top view. Now, how to draw side view for this? He has asked for 3 views. Now, it's easy. Already we have drawn side views for the points. Only thing is, you have to fix the RPP or LPP as per the requirement. Now, let me, for all practical purposes, by default, take left view on RPP. Left view on RPP. Yeah, this is always preferable. Now, do this job. Keep x1, y1 at convenient distance. X dash, y dash. Suppose that if they say one end or nearest end is 40 mm from RPP, definitely you have to consider this, not this one. Final projection, nearest end is 40 mm from RPP means from this point. If nothing is given, you can take any convenient distance, keep a sufficient gap, then start working. Now, here is the reference, x dash, y dash, where you get RPP, whether it is below or above. Wherever you have front view, you get the RPP there. In straight line onwards, you follow only first angle projection. Always RPP is above XY line. RPP is above XY line. Now, 45-degree line, as usual, draw 45-degree line, check twice because you get the difference in the length if there is a small change. Now, A, B. Projected. See, just observe here, I have stopped exactly at 45 degree. Don't proceed unnecessarily. It leads to confusion and also mistakes. Now, where is A? A is very close to XY line. Don't project unnecessarily up. You can judge simply and stop somewhere here and then get intersection. Otherwise, using computer, and use alignment indicator and then move and get exact point. See, this is how you do it. This is A double dash. Then you have B projected up to 45. Now go up. Somewhere here you get approximately little above that you project. Then this becomes your B double dash. Now you join A double dash, B double dash to get the final side view. Okay, it can be any angle. Don't worry about that. Very rarely they ask angle of side plane with respect to x1, y1 or xy. Okay, but these two are important, theta and phi, whether it is given or you are going to specify, identify, you have to note down. If the alpha and beta, simply say alpha and beta. Otherwise, if they ask you to measure, yes, definitely. Don't get confused with apparent angle and true angle. True length always associated with true inclination. Apparent length is always associated with apparent inclination. This is very clear. So, this is how you solve a problem on straight line. So, we'll repeat, the things are very important. Vertical projector and then locus of B in top view area, locus of B in front view area, and these three lines are going to give clue to proceed further and complete the problem. Okay. So, this is actually referred to as standard problem or master problem. Now let me take the same problem on software. Let me take a problem which is inclined to both the planes. Say a line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. The line is inclined at 45 degree THP and 30 degree VP. Draw the projection. This is the standard problem or master problem, we can say. You must understand this very clearly. I am trying to give procedure side by side. So, what all given here? True length of the line is given 80 mm, 45 degree inclination given to HP and 30 degree inclination given to VP. First fix the or draw the projection of one fixed end, that is A. So, draw the projection of fixed end A, that is what I have done, 20 mm OHP, 30 mm in front of VP. Then draw the projection of the line with respect to what? HP. So, we have to give inclination to HB by 45 degree starting from A. So, now I will show you how to do it. So, here let me take 80 mm line, thin line only you have to take, thin line, start from this. So, what is the total length? 80 mm, just press 80 mm and enter using the computer enter tab. Otherwise, if you use mouse, that will vary. Then angle is asking angle, how much is the angle? 45 degree, that is all, it is going to be fixed. Now, you measure how much it is, see this is what 80 mm pakka. So, this is what you have to do whenever you get the problem like this, that is what I have done. Now, you see 45 degree, this is A dash B1 dash, this is not final, that is why I am marking this as B1 dash. You can keep your initial, my initial is MSP, I can say BM dash, then here I can say BS, ABS, okay. So, here it is AB1. So, normally we keep 1 here and 2 for initial positions. So, A dash B1 dash. Next, draw the projections and get the corresponding top view. See here, assuming that the line is inclined only to HP, draw the projections, that is A dash B1 dash, that is front view, and A dash B1 dash is true length as it is parallel to VP. We have assumed it is parallel to VP initially. So, you have to do that. Next, project it and get the top view. So, this is set 1, true length 1, apparent length 1, true length, apparent length. Next, give inclination to VP by 30 degree. So, 30 degree inclination will be given, see as in this previous case you draw a line and do it. How to do it I will tell you. So, you have to give inclination to VP by 30 degree, set this and then fix the value 80 mm only and then enter in the PC tab, that is enter tab, then fix the angle minus 30, then keep this as B. So, this is what you have to do. So, you measure the angle and get the value. So, here is the value. So, this line must be thin line. Please see that whenever you draw a line, before that which type of line you want. So, this is what we have done. So, here is the reference, see that is what I have done for you. Next, get the projection and get the corresponding front view. This is set number 1, true length 1, apparent length 1. Here this becomes apparent true length 2, you are going to get apparent length 2 here, see here true length 2, apparent length 2. Project it and get this. Assuming that the line is inclined only to VP, draw the projections, that is AB2, that is top view, and then AB2 is true length as it is parallel to HP, inclined only to VP. So, this is true length, and A dash B2 dash is the apparent length, that is front view corresponding top view. This is top view corresponding front view, set 1, set 2. Next, you have to draw the locus of the moving end, that is B, locus of B1 dash and B dash, final one is B dash only, here final is B. So, what you have to do is you have to draw arc with A dash B2 dash as center, A dash S, this A dash S center, A dash B2 dash is radius, draw arc. Similarly, AS center, AB1 equal to radius, draw an arc, because this is final top view length, this one is final front view length. So, the orientation is changed. This is the initial, this one is final. So, that is what we have done here. See, draw arc with A dash B2 dash equal to radius A dash as center, get B dash on the locus of B1 dash and B dash. Similarly, you draw arc with A1, AB1 with A dash as A as center, draw arc to get B on the locus of B2 dash and B. So, this is what you have to do. How to check whether the solution whatever we got is the correct one. Now, you draw a vertical line either through B dash or B, both must be on a single vertical projector. That means, the end projector of this line is going to house B dash as well as B. Suppose any deviation, then the solution is wrong. Now, check this, see, B dash and B must be on a single vertical projector. Then join A dash and B dash, this gets you front view and final front view, AB is the final top view. So, this is how you get final solution. Then there is one more very important reference is there, that is distance between end projector. If you measure, you will get some value. In this case, you get 40, the distance between end projectors 40. Okay. So, this is how you proceed with the standard or the master problem, try to understand better. Now, how to get the side view of the line? See, so this is the final with all the data, true length is given, angle with respect to HB is given, and then angle with respect to VP is given. So, this is the references. A dash B1 dash is the true length in front view area and AB2 is the top view area. See, what is top view? Top view is AB and front view is A dash B dash. You do not have to write all this, just you can keep this data, and then finally, whenever the situation demands, then only you name it and then dimension it. Otherwise, whatever the dimensioned in the sheet itself is okay. Then if they ask distance between projector, you write. Here also you identify. That is all. So, this is the final solution. Now, side view, how to draw side view of the line. So, side view of the line is obtained by this method, you know, xy line, x1, y1 you draw, then project top view through 45 degree line to the respective heights. See, A dash is at this height, then project up to that. Otherwise, alignment indicator, you keep this and move and touch this point and move, again you get A double dash. Similarly, B double dash. Otherwise, you project it and then get the intersection, mark A double dash, B double. This is the side view for this problem. See, here only it is clear that it is 20 mm in front of above HP and 30 mm in front of VP. Okay. So, the parameters may be the distance between end projectors will be given, or the two ends distances from HP and VP will be given, and one end of the line is fixed, that will be always given. Very few cases the fixed end will not be given, you have to identify. Next, identify the problems which are actually one end on HP and one otherwise end on VP, etc. Then that I will show you in the next part. See, here we have a problem. A line AB 90 mm long has its end A on HP and 20 mm in front of VP. The line is inclined at 30 degree to HP and 45 degree. Same procedure. Maybe this might have been interchanged. That is all. Otherwise, the same pattern. Draw top view, front view, and left profile view. Okay. Normally, for first quadrant, left profile view is on right plane. Now, just observe here, the end is on HP, okay, and 20 mm in front of VP. I have fixed one end of the line. Then, as usual, you draw inclination to the HP by taking 90 mm long and 30 degree inclination. Similarly, get the corresponding projection. This is front view, true length 1, apparent length 1, you can say. Then this is true length 2, this is true length 2, then corresponding apparent length. You get on xy line itself, that is A dash B2 dash because the A is on HP. Next comes the corresponding set. So, this is set 1, true length 1, apparent length 1, true length 2, apparent length 2. That is in projections of the line, assuming that incline only to HP, incline only to VP. Next comes, only thing is you have to start from a single fixed end. Next, draw locus, procedure is same, then rotate. Either you can rotate first this one or this one, simultaneously you can do. See, then see that B dash and B on a vertical projector. Yes, definitely it will be there, just check. See. Then join AB and A dash B dash, you get the final solution. Corresponding side view, see here it must be very carefully done. A is projected here and it must be projected only up to XY line because A dash is on XY, A is on XY. See, I can even write VP HP here. So, it is on HP. Okay. So, you get this. See, this side view L shape refers to VP of RPP, HP of RPP. Okay. So, one end of the line, that is A is on HP and inclination to VP and HP by 45 degree and 30 degree. Okay. Here is 30 degree. Yes, 30 degree to HP and 45 degree to VP, and corresponding values of alpha and beta are given. See here, this is the value. Next comes the inclination is 30 degree to HP and 45 degree. Only change is end A is instead of on HP in the previous case, I have given on VP. It is reverse, 20 mm over HP. Same procedure you have to follow. First you have to give inclination to HP and get the corresponding top view, that is top view will be on XY line only because A is on VP, and then give inclination to the VP and corresponding front view. Then fix the locus of P1 dash and B dash and this B in both of you. The dimensioning you need not retain because at the end you can do, here procedures and all will distribute. Okay. This is rotation, rotate the line AB1 about A till you reach the locus of B2 at B, and again rotate A dash B2 dash about A dash till you reach the locus of B1 dash at B dash. Join A dash B dash and AB. Before that you check whether it is on a vertical projector, then join. Okay, then you get top view, front view. Then similarly corresponding side view you get, also add side view, that is profile view. Simply is given for, you can either go for left profile view or right profile view, and preferably right profile view you get the value, that is left view on right plane. See here it is on VP, project only up to VP, VP of RPP, then draw this one is up to this is intersection A double dash B double dash. The criticality of the problem is here. So, in previous case, see here is the case, see it is on HP, HP of RPP. In this case it is on VP, it is on VP. Okay. So, this is how you get the solution of the line inclined to both the planes with one end on HP, other end on VP. Now, both, that is end A is on both HP and VP. Now, identified A, if you know, you recall the projection of points, whenever a point is on both HP and VP, you get a single point on XY line. So, then same procedure you have to follow, draw projection of the line, it is inclined only to HP by 30 degree, get the corresponding what, top view, you get definitely on XY line only. Similarly, you get the projection of the line inclined only to VP by 45 degree, okay, get the corresponding, okay, front view on XY line, okay, yes, 45 degree. This is phi, this is theta, this is phi, okay. Yes. Now what you have to do? Fix the loci of B in both front view, top view, that is B1 dash and B dash and B2 and B. Rotate both apparent lengths. You must be very careful here. A dash B2 dash must be rotated and then get B dash on the locus of B1 dash and B dash, and then this one A B1. If you do ulta, then wrong, but be careful. With the dash is there, just in front view you have to rotate in VP area, top view rotate in HP area. Okay, then get B dash and B, and final front view, top view. Then now to check, draw vertical line through this. See, now let me draw vertical line, and then so if you draw vertical line you must reach it. Okay, now keep the projections. Finally, the side view, just observe here, this is the criticality of the problem. Okay. A is touching both HP and VP, okay, VP and HP. So that is what final view projection is this. So this way you can have the number of problems, simple problems on straight lines. Okay. So we will work the typical problems in the next session.